Hi, my name is Daniel Kornev. Um, I'm CPO at DeepPavlov, and today we are starting our 13th community call. We've made a full year. The first community call started at the beginning of last October. We wanted to start it in late September, but we had to give a talk at NVIDIA GTC Fall. It was a fascinating thing, and we did not actually have a chance to make a call in end of September. So last year we started first community call in the beginning of October. The second one was in the October, but in the end of October, and then we made this tradition of running community calls in the end of each month. And so we've run like 12 community calls in English. And then back in April, we decided that we want to run also community calls in Russian in order to get some feedback from the Russian audience. And in total, we've run 18 calls, I think, 80 community calls. Let me check. DeepPavlov Community Calls. And if you go to YouTube, and then you go to DeepPavlov and you go to playlists, you will figure out that we have we have 17 community calls already. So this is an English version for the community call number 13. And that was quite a ride, I would say. We had almost 1,000 views since beginning of last October. And we had different guests. We had invited guests. We had talks about what we've learned from Alexa Price Free. We had features of our new products, features of existing products. We've introduced our DeepPavlov TP, which was an alpha version of our multi-skill AI assistant platform, an open source one. And as we're starting the second year of community calls, we figure out that we have to change the format of community calls. And that's a real problem for us because we're a small research lab. We participate in challenge like Amazon Alexa Prize 3 and 4. We've been really, really fortunate to participate in this challenge. But it also meant that most of our team was dedicated like 24/7 for the challenge. And while we made fantastic contributions to community with DP last year, that was obviously not enough. And hopefully later this year, we will finally be able to open source our social bots made for the competition and make them available to the public. And with that, I would like to talk a little bit about the new format of community calls. We've gathered some very good feedback last day from Russian part of the audience. We've learned that some people want to have some sort of podcasts. Other people want to have things like looks into different kinds of technologies that exist in the market and what kind of things we could contribute to the market. Some people want to have use cases, so they will showcase what has been built using the DeepPavlov technology and how it actually DeepPavlov technology helps people to solve their problems. Some people want to learn more about the new tendencies in the industry. So they're looking forward to hear from our lab, from our staff, what we see as the newest and coolest technology and so on, and hear our opinion, I hope. We also heard that it would be interesting for people to learn about our collaborations with other organizations across the world. For example, what we have done with NVIDIA, for example, where we integrated their NEMO research lab into DeepPavlov. And we integrated it with DP, for example. The idea is to keep talking about our experiences in building things and also invite new guests to us. So we've gathered some great and interesting feedback around what could make our community calls more interesting and exciting. We got this feedback yesterday. We keep getting this kind of feedback, and in the next community call in end of October, we're going to try to implement some of those great ideas and to make this community call more interesting and exciting for the audience. Okay, so what else I'm going to talk today about is our latest releases of our DeepPavlov library. Talk a little bit about DeepPavlov Dream, and share a small secret, small great news that we have. And if you have any questions, feel free to join us on Zoom. To join us on Zoom, all you need to do is to add a calendar invitation to your Outlook or Gmail or calendar app on your iPhone or macOS. And otherwise, you feel free to ask me questions in our community call on YouTube. I will open the current community call to see what's going on there. Give me a moment. So we have the community call number 13, and it should be happening at any moment. Yep, that's the phone or right. So I don't have any community call questions right now, but feel free to ask questions as you're watching the video. Okay, so latest releases. We have made a couple of big and small releases in 1 month. In 0.17, we shaped relation extraction. That's one of the new components we made available to the community in I would say almost a year. I'm not saying that we haven't shipped any kind of new components over the year, but this is one of the newest components, and this is a special component because it was built by one of our Google Summer of Code students, Anastasia Sidova, and it's available for both Russian and English. And it was built using framework PyTorch, and we actually posted a blog post about it. Here is a link. It's available right here on the website. I could probably, I believe, could probably even maybe make it more accessible. I think I have a short link about this kind of stuff. Let me take a look. And if I don't have the link, let me check. I can actually make a short link right now. Let me click on it. Yep. And I can create a short link right now. And I'm gonna say and I can actually edit the slides so that you could see this kind of link right here. So you can use this link right here, bit.ly/relaxed in DP, and this is gonna lead you to the very same blog post. Okay, so the cool thing is relation extraction is also one of the things that used to be available only through commercial libraries and web services. In our case, it's open source. It's part of DeepPavlov Library. It's one of the models of DeepPavlov Library. And it was trained for English on RED dataset. For Russia, it was on RURED dataset, if I'm not mistaken. And for English language, it captures relations, like around 100 relations between different kind of entities. For Russian language, it's about 30 relations. And basically, you can provide as inputs tokens that you can extract using NER from the plain text, and then it would extract relations if there are any relations available, make them available to you also as tokens, and then you can use this data to either build your knowledge graph from the text that you extract the data from it, or you can use it in your conversational AI experiences, and it will be available for you. So this is the first release of something built by our Google Summer of Code student. We are super happy about it. And if you want to learn more about it, you can use the link here. You can also watch our previous community call and learn more about stuff happening there. Speaking of what we shipped just like a couple of days ago, 0.17.1, we started building support for native Python pipelines in DeepPavlov Library. So just to remind you, when you want to build an NLP solution, be that a general NLP solution or conversational AI solution, you usually want to use lots of different ML models in NLP. And DeepPavlov as a library makes it possible for you to easily build this kind of pipelines. So, for example, if you want to build a component that can extract triplets, which basically are like a couple of intents, a couple of entities and relations between them, you could build this as a pipeline. So you would start with processing the text. You can then extract entities from the text. Then you can run relation extraction mentioned earlier. As the next component, which as input would grab tokens coming out from the NLP NER model, and then could output those extracted entities and relations between them as a final triplet extraction component. So this is just one of the examples of what pipeline is. And originally, DeepPavlov as a library provided people with an opportunity to build this kind of models using our pipelines, but you had to describe your pipelines in JSON. And while we all love JSON, it's a bit a stranger for Python developers. So they had to like write those pipelines in JSON, then import them into DeepPavlov library or build into their own components and have to switch between those things. With the 0.17.1 release, you can now do things a bit differently. You can now use our Python pipelines. So you can use this new object we call model, which is basically a representation of the pipelines we already had in the system. And you have a few inputs like X, which is a vector of things you want to bring into the system. You might also add Y as a training data, but this is not shown in the demo here on the screenshot. And you can also specify what is the final data that you can get as output. And then you have to build a pipe. And then this pipe, which is sort of named like a tuple of sorts, you can specify those element objects, which each of them is representing a component in the pipeline. And this component, it can be something from the library itself, like ASR, which is our integration of NEMO components into the DeepPavlov library. Or it can be something built by you. Like, for example, in this case, upper is a Python Lambda function, and you can build a pipeline through them, and then you can run this model against some of the input. And in this case, which is quite fascinating in my perspective, you can grab data which is not even text. It can be a WAV file. You can transform it to text. Then you can make a second operation on top of it within your pipeline and run it and get the result. Now, the final result, as you can see here, is not entirely fascinating itself. It's just an output that is an output. But nonetheless, you can easily build, as example, triplet extraction using the same approach, using Python native mechanics. And this is something that is available for you in DeepPavlov Library 0.17.1 release right today. And we are going to ship, we're going to post a blog post with the details probably tomorrow morning, and they will be available as well. But the library is available today, so all you need to do is to go to github.com/deepmeep/deeppavlov, and that's where you can grab the latest release. Okay, so our lovely GoBot is still slippering in its release. It's slippering to 0.17.2. And as I said before, it's going to have this long tscope autograde with a slot filling, intent catcher, raster formats, and all of this stuff will be available in the next version of library. Now, with all of that said, we also are working again on open sourcing our DeepPavlov Dream AI assistant. I'm going to show you a couple of things. So last year, just about like last year, we wanted to open source our DeepPavlov Dream, which was a social bot made for Alexa Prize 3 competition. And while we wanted to open source it, I mean, I can show you. This is the original /assistant repository where we had the social bot transformed into AI assistant. We even been running it for some time and demo at the DeepPavlov.ai. So it's right here. It wasn't called Deep, it was called Dream. But when Alexa Prize 4 challenge was announced, we had to close the demo, and we wanted to give you at least something. So we created something called DP. And it was announced originally at NVIDIA GTC Fall, so like almost 1 year ago. And it was very small multi-skill AI assistant. It was a representation of Gertie from the movie The Moon, made by Duncan Jones, released back in 2009. And it was a very simple, quick, dirty demo, but it was readily available for the people, and you could grab and build things with it. Now, after Alexa Prize 4 challenge has ended for us and for the rest of the teams, we decided to open source the updated version of the DeepPavlov Dream as an AI assistant. And here you can see a lot of different branches here. One of them, Common B, is going to be a main branch in DeepMIP/DP, which is now Dream, in the next, probably next few months. And here you can see there are lots of different components that you will be able to grab and use. So just to give you an idea that currently we have already components like skills. There are a few skills here. We have annotators in the pipeline, like motions, extraction of entities, and linking them with Wikipedia, intent catching, sentence segmentation, and spelling pre-processing. But this is just a very small number of components, and we've organized them into this something we call distributives, like in Linux. And the distributives are, practically speaking, consisting of two kinds of things. There is a Docker Compose file, which explains what kind of services we have in the system. And then we have this pipeline, which explains to our DeepPavlov agent how to put all of these components together to organize your multi-skill AI assistant, how everything should work based on the pipeline. Here I can give you a high-level perspective how it looks like. So when we go to the Dream, there is this architecture. This is the architecture of DP. So you start with annotators, and your response goes to skill selectors, and it goes to skills, and we go to candidate annotators, and we go to response selectors, which picks the best response, or maybe combines some of the responses together. Then we go back to the user. And this is all described in this pipeline underscore candidate.json, where everything is here. And when we will make this transition from common B to main branch, you will have way more annotators. This is a list of annotators we have here, which is like wiki parsers, speech function classifiers, and predictors. We have topic recommendation. We have fact retrieval, entity storer, entity detection, which is a fascinating thing, and many other components here which are available, which will be available to you. We will have way more skills, like here. And you can notice DFF here, which is actually a new finite state machine framework we designed for rapid development of scenario-driven skills for social bots and AI assistants. And we have other skills as well here. And we have even one generative skill which knowledge grounding skill, which uses per line model from the last year from Facebook that generates responses using some context gathered by the system during the conversation with the user. So all of this is going to be available in the next few months. It will be in the main branch, but well, you can definitely grab the Common B branch right now and try to experiment with it. But before that, you would need several 1080 Ti NVIDIA GTX GPU cards and have like a huge amount of RAM to run the entire thing. And that's also one of the reasons why we are not going to make this switch to main branch just yet, because we're still figuring out how we're going to make it available for the general public. And we are thinking that because our assistant eventually will be also available here, instead of DP, we will also have Dream. We probably will find some way for you to reuse the components of the assistant for free, but we're going to make it available in a limited way. So we'll probably introduce some kind of API calls, something like that. Not because we don't want for you to run your Shiny assistants based on our platform, but because we have limited resources and we want to make it available to as many people as possible. So I could try out the whole thing before they're going to jumpstart development of big systems in their own environments. So that's about the news, what's happening here. So there's a lot of work here, and you can already take a look at our social bot. So anyway, it's sort of open source again already. Is just we really want for you to not just look into the code, but also make it available for you to run it on your own machines. One more thing that I wanted to share with you today is very close to my heart. So when we started building our Alexa Price for Social bot back in last year, our leader, Mikhail Burtsev, proposed a research direction for us, how to build this kind of multi-skill AI assistants. And if the topic for the first year for 2020, 2019 was that we are making it possible for people to build multi-skill AI assistants using DeepPavlov Dream and DeepPavlov Agent, then for last year and for this year and for a few next years, we are focused on ways to design goal-aware or goal-oriented open domain dialogue systems, or social bots, if you like, or personal AI assistants. And the thing is, if you're working a lot in the conversational AI space, you certainly heard that there is a task-oriented systems and goal-oriented systems, and usually these two are the same. But the truth is, task-oriented systems are very concrete. You want to solve a very particular task. You have a pragmatic conversation with your AI assistant. It can be ordering a pizza, buying new house, I don't know, or ordering, booking ticket on an airplane and so on. It's so old and boring task of sorts. But then when you want to talk about the goal-oriented systems, and that's where the problem comes in, because goal-oriented system is about goals, and goals are not the same as tasks. Goals can be clear or unclear. They can be quite understandable. They can be very ephemeric. So I can have a goal of having a great dinner today, and then I could decompose that goal into the tasks. But maybe one of the elements of the goal is to have my friends with me, and maybe have someone new, and I don't even know how to make it happen. It's not a very complete task. It's not like I can ask assistant to bring me a cool friend today. Or even I could ask, it would probably never end with anything good, because this is like ephemeral task of sorts. And the thing is, goal-oriented systems are not the same as task-oriented, right? And when we started working with this kind of research, we realized that the system that is capable of being goal-oriented, or goal-aware, as it was called originally by Mikhail, the systems have to understand conversational goals of the user. And in open domain conversation, these goals are even more different than in the task-oriented case. So when we want to talk with a social bot, why do people do that? In our experience, when we worked with Alexa Price 3 and Alexa Price 4 users, we've seen that people came with very different kinds of reasons. They wanted to come and talk to an AI assistant because they wanted to be entertained, or they wanted to share great news, or they wanted to be heard and got emotional support, or they wanted to yell at it, or they wanted to play with it like kids. There are lots of kids because of coronavirus lockdowns across the world. Lots of kids talk to our assistant, to our social bot. And it means that reasons why people are coming to social bots are quite different, and they cannot be equal to tasks, but they can be probably seen as sequences of tasks. Sometimes you cannot decompose a goal into a particular task, as I said before. And when we realized that, we realized also that we want to have a framework that would allow us to control dialogue from single turn approach to a situation where people would have a tool. I mean, developers of the social bots and the AI system will have a tool that would allow them to control dialogue strategically. And this research, in essence, led us to discovery of discourse from language theory, and not just dialogue acts, because we used dialogue acts during Alexa Prize 3, and Gandrock, the winner of Alexa Prize 2, they created a fantastic schema called Midas. And for us, the problem was that those dialogue acts, they are great for understanding of what the current user utterance is kind of action within the conversation, but they don't really, this kind of schemas, they don't really tell you what is the role of those utterances in the larger architecture of the dialogue. But if you look into the theory of speech functions and discourse from Holiday and Eggenslate, you can see that actually there is connection between those things. And they basically build you a bridge between what is said right now and what is said in general in the conversation. We can see that actually conversation is like lots of trees, like lots of branches within the bigger tree of the conversation. And those branches, they have connections between themselves, and there is transitions. And in the case of Holiday's theory of discourse, each branch starts with opening moves, and then all other utterances made by illocutors are other kinds of moves, discourse moves. And with that, we decided that we can build this kind of speech function classifier. I can show you. It should be one of the branches here, and here it is. So you go to our annotators, and here we have the speech function classifier and speech function predictor. So the speech function classifier basically grabs as an input user utterance, and then we identify the speech function. So this is just in some experiments, and this is a real system. So we have an annotation, we send a payload to the system, and then we identify the speech function and the probability of the speech function. And after that, we decided that we actually want to build an entire environment around building open domain skills with the speech functions. And when we focused on this kind of stuff, we realized that we want to build a framework for building skills. And those skills would allow us and our users to build open domain skills. And these open domain skills would actually be able to use this kind of speech functions. And so the big news that I want to share with you is back in the summer of this year, we decided to submit an article for a paper, a demo paper for EMNLP workshop on computational approaches to discourse. And last week, our paper was accepted for EMNLP CODI 2021 workshop. And it's going to feature, this is a part of a paper, and it's going to feature this tool here. This is how the tool is going to look like. It's a first ever extension for Visual Studio Code that makes it possible for users to build open domain scenario-driven skills using this theory of speech functions and discourse merge. So imagine that you're starting with a canvas like in Draw, because this is basically a flying version Draw integrated into Visual Studio Code. And you start new block and you specify which kind of speech function that block is. And because we have the speech function for the block and we have a speech function predictor, we can predict which kind of the next speech functions could follow, making this open domain conversation sequential and interactional. And based on that, you can generate the entire diagram of your conversation using the speech functions. And then you can transform that into a new DSL we designed during this project of building this development environment. And this development framework called DFF, Dialog Flow Framework, got a new DSL. Here's how it looks like flows, graph, response, transitions, and it's very, very short. It was inspired originally by ESTDM, which was built by Umora University, who were winners of the last Alexa Prize Challenge. And then we significantly reworked it so much that right now we don't have any code left from original ESTDM framework. And it actually can be integrated with DeepPavlov Dream. And in the next few months, you will be able to grab this tool and use it to build scenario-driven skills and use this recommendation mechanism, show suggestions as shown here on the screenshot, to actually build this open domain skills using our technology. So that's a small surprise of sorts. We're gonna feature our tool. We call it the DIDDE, which means discourse-driven integrated dialog development environment. We're going to feature next month in November, mid-November, in Dominican Republic at the EMNLP workshop. And the tool is going to be available also in the coming, in the next few months. Public beta of sorts going to be available hopefully by the end of this year to you. And this is the news that I wanted to share, I was anxious to share with you. Okay, so that sort of wrap up our community call for today. Starting with the next community call, we are going to change format. We're going to reach out to more areas, more communities across the world to bring more of you here. And we're going to bring some cool guests and have conversations, maybe some sort of podcast and so on. So stay tuned for the next community calls of the second year community calls at DeepPavlov. And we are reminding you that we are building this conversation via DeepPavlov Stack. And our DeepPavlov Dream platform is already available in the Common B branch of deepim/dream at github.com. And we encourage you to check out DP right now and come back to us in the next few months and the end of October, end of November, and end of December, and so on, to get the tools into your hands and start building your open source multi-skill AI assistants using the power technology. Thank you, and see you next October.